The Edison Electric Institute reports that 33% of all electrical accidents occurred at voltages from 120 to 600 volts. 6% of the total fatalities were caused by shock or burns at voltages below 600 volts. 9% of these low-voltage accidents involve metermen. As meter installations become more complex, with higher voltage and current, metermen must be even more alert to the hazards and careful to employ safe work practices. Metermen are subject to 4 basic types of hazards: electric shock, flash burns, cuts, and falls. Perhaps the most dangerous of these is electric shock. Flash burns, however, are by far the most frequent cause of serious injury to metermen. Cuts and falls are also frequent accidents. In the next few minutes, we'll examine each of these hazards in detail. Then we'll look at the safeguards you have available to keep these hazards from becoming an accident. Finally, we'll cover some of the applications of these safeguards to protect you from the hazards you face each day as a meterman. Let's take the first hazard, electric shock. Shock is the most dangerous. Metermen should remember the natural law or rule of electricity. It continually seeks a path to ground or to an opposite polarity. When a meterman becomes a part of that path, he will receive an electric shock. The severity of such a shock depends on the path of the current, hand to foot or hand to hand, the duration of the contact, and the current flow. Under conditions where a low resistance fault path is established and the path flows through the heart, even 120 volts could prove fatal. Voltages in the lower ranges usually cause muscle contractions. These involuntary movements often cause a person to fall against some sharp object, and should he have an energized conductor in his hand, he may not be able to let go. Metermen should never put themselves in a position to give electricity a path through their body. If you respect this natural law and abide by the work procedures outlined, this type of serious accident can be prevented. Now, while electrical shock poses the greatest threat to metermen, the second hazard, flash burns, causes the largest number of serious injuries. It is important to know what causes an electric flash. In general, a flash is caused by interrupting a heavy flow of current. The result is a hot flash of radiant energy and a spray of molten metal particles. An electric flash can result from improperly placing a tool or piece of equipment so that it creates a short or fault. Flashes also occur when a meter is installed or removed under heavy electrical load. Don't underestimate the damage which a low-voltage flash may cause. Low-voltage flashes can cause first, second, or third-degree burns. Molten metal from an electrical flash can cause severe damage to the eyes. The third type of hazard common to metermen is cuts. While cuts are not usually as serious as shock and flash accidents, they do occur frequently. Many cuts are caused by broken meter covers. Sharp edges on cabinets, sockets, and open windows are also dangerous. The fourth hazard, falls. Falls can be caused by poor housekeeping on the job site. Improper use of ladders or makeshift substitutes frequently result in falls. Now that we've considered the hazards, we'll look into safeguards and work procedures which you can utilize to minimize the possibility of injury. Remember, a safeguard can keep a hazard from becoming an accident. We sometimes think of safeguards only in terms of safety equipment. The most important safeguard is a trained mind, alert to spot hazards and plan how to prevent them from becoming an accident. Take time to look the job over carefully. Make it a habit to methodically look for each of the hazards. Where can shorts, flashes, cuts, and falls occur? Well, by analyzing the situation and planning the work step by step, you can avoid these hazards and use the safeguards to keep the hazards from becoming an accident. This planning is the mark of a master craftsman and will enable you to work more efficiently and safely. The pre-job survey can be divided into 5 major parts: work area, meter socket, test switch, meter, and equipment and materials. Survey the work area. Consider the accessibility of the meter and the condition of the surroundings. Check for flammable liquids or gases which could be explosive in the event of a flash. Consider the proximity of exposed live parts and ground. Now, inspect the meter socket. Be sure the socket is company approved. Is the wiring within the meter socket in good condition? In new installations, check for nicks and cuts in insulation of the wire that would allow possible short circuits. Be sure all connections are tight. In older meter installations, also check the insulation. It should not be badly worn or cracked. If the insulation is so worn that work cannot be done safely, the incoming service should be disconnected and the meter work accomplished de-energized. The meter socket or cabinet should be properly grounded. Make sure the socket is properly secured to the wall and properly aligned. Not this. The cabinet is not flush against the wall at the top. Inspect for broken insulating blocks and improper alignment of clips. Now let's talk about meter jobs that require test switches. Check the general condition of the test switch. Check switch phase sequence and secondary wiring. If barriers between line parts and ground are low or completely absent, special caution is required. Check for proper wiring to be sure you do not close in on a ground. Now, the meters. Is that the right meter to be used for a specific location? Check the nameplate, voltage, and type of meter. Check the condition of the glass, the seal, and the arrestor gap. Be sure you have the right equipment and material on hand to do the job safely. This completes the pre-job survey. The work area, meter sockets, test switches, meters, equipment, and material. We've talked a lot about our first safeguard, the pre-job survey. A second safeguard is the one most people think of first, safety equipment. Your company provides you with the most up-to-date and dependable protective equipment, and it should be used at every opportunity. The hard hat not only protects the wearer from accidental blows to the head, but it also has electrical insulating properties which protect the wearer's head from electrical contact. This meterman, connecting a secondary, could have received a bad shock when his head hit the transformer terminal, had he not been wearing his hard hat. This meterman could have suffered a severe gash on the head when he raised up under the window, had he not been wearing his hard hat. Safety goggles and face shields protect the eyes from molten metal particles and other flying objects. They are impact resistant, lightweight, and easy to clean. Here's a good example of a situation where eye protection should be used. The meter glass is cracked. Notice the man also has on a pair of special cut-resistant gloves. These gloves protect the meterman's hands from cuts. Cut-resistant gloves should be used whenever working where glass is broken or might be broken. Here, the cracked glass has broken, but the meterman's hands are protected. Low-voltage rubber gloves are designed primarily for metermen to protect them from electrical shock. These gloves are periodically tested and should be inspected before use. The light leather protectors should always be worn over the rubber gloves. A variety of insulated tools, if used properly, can protect the user from accidental contact with energized parts. No, not those water pumps. Use the insulated socket wrench and make sure it is in good condition, with the insulation intact. Test instruments are often overlooked as far as safety is concerned. However, proper selection and use of test instruments is an important part of doing a job safely. Use only approved testing instruments. They are more accurate and have proper scales which will give you results upon which you can depend. Keep insulation on instrument probes in good condition. So far, we've discussed the hazards metermen face, the safeguards available to keep these hazards from becoming an accident, and now we're ready for some applications of these safeguards to your daily work. Let's talk about safe procedures for installing, removing, and testing meters. First of all, the installation of meters. Care should be exercised when carrying meters. A dropped meter not only means damage to expensive metering equipment, but there is danger from flying glass. Before a meter is installed in a new installation or where rework has been accomplished, a thorough voltage check of the socket should be made. This will prevent installing a meter on a ground, short, or feedback. These conditions caused by improper wiring will result in a dangerous flash. When inserting the meter into the socket, carefully line up the lower bayonets and socket jaws first. The lower jaws are unenergized, so there is less chance for an accident. Then push the meter in. Do not pound. Also, notice the use of leather or cut-resistant gloves as a protection in case the glass should break. In the more complex meter installation using current transformer CTs, additional hazards exist. For meter installations that require secondary wiring from current transformers or potential transformers, Keep in mind that they are located on the incoming service where available fault current is highest. Proper care should be taken when making potential connections. Do not cause phase-to-ground or phase-to-phase faults. When installing secondary wiring for CTs mounted in pad-mounted transformers, be aware of the close proximity of grounded and energized parts. In instrument transformer metering jobs where high load current is present, special care should be taken not to open the current transformer secondary shorting bar until the wiring is complete. High voltage buildups are possible across the open circuit. With full load current in the conductor, the voltmeter is reading about 190 volts across the open secondary of the CT. In instrument transformer rated meter jobs, test switches are another hazard. Close proximity of line and grounded terminals call for special care when connecting leads or using tools. When working above test switches, be careful not to drop metallic parts on the test switch. The result can be a serious flash. Make sure all current circuit connections are tight so no open circuits are possible. Again, high voltage buildup can result and you may receive a shock. When removing meters, there are two different situations you will encounter. One is a meter to be removed under normal conditions, such as a routine change-out for a shop test. The second is a meter to be removed where trouble is suspected. The normal procedure includes a visual check of the cabinet for unusual conditions, a close inspection of the meter to check its condition, and then removal of any heavy load flowing through the meter. Many recent installations are equipped with lever-operated bypass switches, which allow the load current to be shunted around the meter, so that the meter can be removed safely without interrupting service to the customer. The bypass switch should never be operated without a meter or jumpers in the socket. These switches are not designed to pick up or break a load, as you can see. On older installations where test blocks or socket wrench-operated bypasses are used, special care and insulated tools are necessary to bypass the load safely. Where no load bypass means are available, you will have to use the customer's main switch to disconnect any heavy loads flowing through the meter. When meters are removed where trouble is suspected, the same general procedure as outlined above should be followed, except power should always be switched off the meter circuit. Complete personal protective equipment should be used, including hard hat, face shield, gloves, and long-sleeve shirt buttoned at the wrist. Finally, let's talk about safety in testing or repairing meters in the field. Accident records show that many electric flashes occur when metermen are testing or repairing meters in the field. Use of the proper insulated tool can be very helpful in preventing this kind of accident. Perhaps flashes occur frequently during testing because the meterman gets so involved in testing he forgets about the hazards of the job. Care and planning is required for tests to be conducted safely. When testing, the meterman needs to remember that energized and grounded parts are very close together on test switches and test jacks. Use fused leads to minimize fault current when shorts or grounds occur. Now let's summarize what we've discussed. We've discussed the hazards you will encounter, the safeguards you can use to keep these hazards from becoming an accident, and some applications showing how these safeguards can be applied to job situations. We said that metermen were exposed to 4 major hazards: electric shock, flash burns, cuts, and falls. Next, we saw how safeguards can be used to keep these hazards from becoming accidents. Of the safeguards available, 2 are most important. First, the pre-job survey. Take time to observe and plan. Remember to methodically look for each of the common hazards: shock, flash, cuts, and falls. See how you can plan to avoid the hazards that cause accidents. Second, use your protective equipment. And finally, apply what you know. If you will remain alert, you can keep that hazard from becoming an accident. Don't get caught when you know better.